Okay, in this video we're going to talk about a remainder theorem. Now, remainder theorem help us to find the remainder when a polynomial is divided by a divisor, right? And the divisor will be in a factor form, right? Okay, the general form that we look at is f of x, which is the polynomial, and x minus a, which is our divisor, right? Now when this polynomial is divided by this divisor here, you will have a value of a from here, right? Now that value of a is basically setting the divisor equal to 0 and then solving for x. That is where you will be getting a value of a. Now this value of a you are going to substitute back in your polynomial function, and whatever result you get is the remainder. Okay, so this is the general form. If you remember this will be very easy for you. This polynomial, divisor, and then f of a, right? Now a is going to come from here, right? Substitute here, you get the remainder, right? So let's do an example, and let's see if it makes sense. Okay, you have example 1 here. Calculate the remainder when the polynomial x cube minus 2x plus 1 is divided by 3x minus 2, right? Now you have your polynomial function. Like I was saying, you'll have your polynomial function f of x, right? Then you'll have a divisor x minus a, right? Then when you substitute your value of a in the polynomial function, you will get your remainder, and this a will be coming from here. We'll say x minus a is equal to 0, then solve for x, you'll get x is equal to a. Now this value of a, you put it here in the polynomial function, and whatever result you get is the remainder, right? So let's do this example. You have your polynomial here and you have your divisor here. So the very first step is you set the divisor equal to 0 and then solve for x, right? So set the divisor equal to 0. That means 3x minus 2, you have to set it to 0 and then solve for x. Okay, so that will be 3x minus 2, set it to 0, and then from there you solve for x. So if I solve for x, I'll have to take negative to the other side, so I'll have to add 2 to both sides. Cancel this. I have 3x here and positive to this side. So solving for x, your x will be basically 2/3, right? Now this is what we call x is equal to a. This is our x and this is our a, right? That is what we mean by this, x is equal to a. Now what we have to do is we have to take this value of a, this a, and substitute in this function here. Wherever you see x, you substitute a there. That is what we say f of a, right? So wherever you see x, you will substitute this value here, right? 2/3, and then whatever result you get, that will be your remainder. So that is what we mean by all of this process here, right? So we are left with the second step. This step will give you the remainder. So step 2, we have to do this f of a, and this will give us our r, right? So our f of x function here was x cube minus 2x plus 1. Okay, x cube minus 2x plus 1. Now we will have f of a, right? And that is same as f of 2 over 3, f of 2 over 3. So that means we'll have 2 over 3 whole thing cube, substitute here, minus 2 into 2 over 3 plus 1. Okay, so evaluate all this, use a calculator, you'll get your answer as negative 1 over 27, right? Now negative 1 over 27 is basically what? Your value of r, or we say the remainder. So when this polynomial, right, I'm writing here, when x cube minus 2x plus 1 is divided by, see the remainder, 3x minus 2 is divided by 3x minus 2, the remainder is negative 1 over 27. That is the answer, right? So be careful of the steps. Okay, let's do another example. Example number 2. This one is going to use the similar concept, but what we are going to find here is the value of a, right? Determine the value of a if this polynomial here has a remainder of 8. So this time the remainder is given, right? Remainder of 8 when divided by x minus 4. So the divisor is given here. You have the divisor. Let me just write it down. You have the divisor as x minus 4. You have the remainder here as 8. And you have the polynomial, of course, there. So all of this is the polynomial, right? So this time there's a part missing from the polynomial, right? That is what you have to find. The same process will be carried out here, right? But we are just finding the value of a. Okay, so let's do this using the same concept. So as usual, your first step will be, step 1 is you set the divisor equal to 0, then you solve for x, okay? So your divisor there is x minus 4. So x minus 4, let it to be 0. Then if you solve for x, you'll have to plus 4 both sides. Cancel this, so x comes to positive 4, right? Now what I'm going to do, I'm going to substitute this value of x into this function here, and I already know the remainder, which is 8. So that means if I do this, if I do f of 4, right, my remainder will come to 8. This is what I know because the question already stated this, right? But we have to find the value of a. So all these places we are going to substitute x is equal to 4. So wherever you see x, you'll put 4 there, 4 there, 4 there, and this will be equal to our remainder, which is 8. Then from there, algebraically, we are going to solve for the value of a, right? So let's do step 2. In step 2, we have to do this f of a, which will give us our remainder, right? So our r will be basically coming from x cube minus 3a x squared minus 8x minus 8, right? Now, like I said, wherever you see x, you are going to substitute 4, and our value of r you already know that it was 8. The remainder is 8, right? So whatever you know, put it down. We have 8 here. Now our value of x that we found was 4, right? So wherever you see x, substitute 4. So it will be 4 cubed minus 3a into 4 squared minus 8 into 4 minus 8, right? Now if you do that, 4 cube is equal to 64 minus 4 squared is 16 times 3 is 48, and you have a here, and then 8 fours are minus 32, and then minus 8, right? Now all the like terms you can add and subtract them. So 64 minus 32 minus 8, those are all like terms, right? So you can take care of that. That will be basically 24. When you do 64 minus 32 minus 8, it will come to 24, and then this is minus 48a, and this side you have 8, right? So take 24 the other side, it will be 8 minus 24 is equal to minus 48a, right? So 28 minus 24 is minus 16, and this is equal to minus 48a, right? Now you need the value of a, so divide by minus 48, cancel this, value of a comes to 1/3. Negative 16 divided by negative 48 is 1/3. So that means the value of a here is 1/3, and that is what our question was asking for. We have to determine the value of a if this polynomial has a remainder of 8 when divided by x minus 4. Okay, so that is how we do it. Those are the steps. Step 1, we did this, and then we got x equal to 4. Then step 2, we know that f of a is equal to r. Then we know the value of r, and then in place of x we substitute our value of a, and then we algebraically solve for the value of a here that we are looking for, right? It comes to 1/3.